Hello viewers, I Nilofar welcome you to the session on index numbers. In this unit, we'll study the meaning of index numbers, its features, the types of index numbers, problems of index numbers, its uses and methods of constructing index numbers. Before proceeding to study the various methods of index numbers such as simple or unweighted and weighted method, we'll first acquaint ourselves with the terms which are going to be used in the discussion, what we shall discuss about these topics. Let's understand the meaning of index numbers before proceeding further. An index number is a statistical measure designed to show changes in a variable or a group of related variables with respect to time, geographic location, or other characteristics such as income, profession, etc. These changes may pertain to the price of a commodity or a group of commodities, the physical quantity of a product or a group of products, or to such characteristics as income and intelligence. Whenever an index number is designed to measure the relative changes in the level of a certain phenomena pertaining to a single term, it is termed as simple or univariate index number. Otherwise, it is termed as composite index numbers. It is a statistical technique used in measuring the composite change in several similar economic variables over time. It measures only the composite change because prices of some of the commodities may be increasing while those of the others may be decreasing, and rates of increase or decrease may be different for different commodities. In other words of Croxton and Cordon, index numbers are devices measuring differences in magnitude of a group of related variables. First one, index number is a special type of average. It is a special type of average that provides a measurement of relative changes in the level of a certain phenomena from time to time or from place to place. It is because it can be used to compare two or more series which are composed of different types of items or even expressed in different types of units. Second characteristics, index numbers measures changes not capable of direct measurement. The changes in magnitude which are not capable of direct measurement due to complex nature of the field. Third one, index numbers are expressed in percentages. Index numbers are expressed in percentages to show the extent of relative changes. However, percentage sign is never used. Fourth point, index numbers are of comparison. Index numbers are used to compare relative changes in a variable or a group of related variables from time to time and from place to place. Index numbers may be broadly classified into three following categories. The first one, price index numbers. Price index numbers are the most frequently used index numbers. They are indicators which reflect the relative changes in the level of prices over a period of time or geographical locations. Price index numbers are useful in studying price movements with a view of analyzing their causes as well as to determine their effect on the economy. Second type, quantity index numbers. Quantity index numbers are designed to measure the changes in quantum or volume of goods produced, consumed or marketed. The changes may concern periods of time such as production of a commodity over a number of months, etc. Third type, value index numbers. Value index numbers are designed to compare changes in the money value of the transaction, consumption or sale in two periods of time. Multiplication of a price given by small p by the quantity q of the commodity produced, marketed or sold gives the total money value PQ of the production, transaction or sale. The various uses of index numbers are given as follows. First one, index numbers are rightly termed as economic barometers as they measure the pressure of economic and business behavior. They are indispensable for any organization in framing suitable policies and formulation of executive decisions. For example, index numbers which reflect the journal price level and in particular the consumer price index numbers are useful in determining the quantum of additional wages or dearness allowances to compensate for the change in the cost of living. Now the second one, index numbers are used in forecasting future trend. It can be used forecasting future trend of phenomena under consideration. Third point, index numbers are used for deflation. The index numbers are used to calculate the real wages from the nominal wages so as to allow for the changes in the price level. The various problems involved in the construction of index numbers are given as the first one, purposes of index numbers. The first step in the construction of an index number is to decide the purpose for which it is needed. All index numbers do not serve the same purpose. For example, if the purpose is to study the cost of living index, the class of people from which the index is designed, that is low income group, middle income group, agriculture or industrial workers, etc., should be clearly specified because the consumption pattern of all the commodities by the people of different classes varies considerably. Second point, selection of items. Once the purpose of the index number is explicitly specified, the next problem is the selection of items to be included for its construction. It is not possible to include all the items or commodities in the construction in an index numbers for reasons of economy and ease of calculations. Only those items should be included in the construction of index number as would make the index more representative. It is also necessary to decide the quality of the items to be included in the index. Third point, selection of base period. Every index number is associated with a base period. The base period is the period of time, usually a year and sometimes a week or a month, that is selected for comparison of the relative changes in the level of phenomena from time to time. The index for base period is always taken as 100. The choice of base period is very critical in the construction of an index number. The following points should be kept in mind while selecting a base period. First point, the base period should be a period of normal and stable economic conditions. That is, the base period should be free from abnormalities like war, widespread earthquake, flood, famine, etc. Second point, the base period should not be too distant in the past. Third point, choice of fixed base or chain base. Fourth one, collection of data. The data for the construction of index numbers must be from reliable sources. The basic principle of data collection, that is accuracy, suitability, comparability and adequacy, should be kept in mind in using secondary data. Let's see the fifth one, type of average to be used. As index numbers are specialized averages, a decision has to make as to which particular average should be used for constructing the index. The arithmetic mean and the geometric mean are usually used for this purpose. In certain cases, the median is also used. Now let's come to the sixth one, selection of appropriate weights. The system of assigning appropriate weight to various items is of fundamental importance and constitutes an important aspect of construction of the index numbers. Most of the index numbers are obtained after assigning appropriate weights to different items, keeping in view the relative importance in the group. The seventh point, selection of an appropriate formula. Several formulas have been devised for constructing the index, which works under different assumptions and give different results. Care must be taken to select the most appropriate formula depending upon the purpose of constructing index and the data available for the same. A large number of formulae have been devised for constructing the index numbers. The various methods of constructing index numbers can be broadly divided into two classes. That is, simple or unweighted method. Second, weighted method. In case of simple or unweighted method, index numbers are constructed without assigning weight to the different items. Whereas in the weighted method, index numbers are constructed after assigning weights to different items according to their relative importance in the group. Unweighted index numbers can further be divided into two categories, that is, simple aggregate method and simple average of relative method. Similarly, weighted index numbers can be also divided into two categories, that is, weighted aggregate methods and weighted average of relative method. This is the simplest of all the methods of constructing index numbers for a group of items. Under this method, the price index for a group of items, that is denoted by capital P, is obtained by expressing the aggregate of prices of all the items in the current year as a percentage of the aggregate of prices in the base year. So symbolically, we can represent it as P01 equals to sigma P1 divided by sigma P0 times 100 or multiplied by 100. Where sigma P1 is the aggregate of prices of all the selected items in the current year and sigma P0 is the aggregate of the prices of the same items in the base year. This method, though simple, is not reliable and has the following limitations. First limitation, the index number obtained by this method is not reliable as it is affected by the units in which prices are quoted. Second one, the index number obtained by this method is influenced by commodities with large price quotations. That is, the commodities which are highly priced exert a greater influence on the price index than the commodities which are low priced. Third limitation, the relative importance of various commodities is not taken into account. Let's see an example here. From the following data, calculate price index for 2005 using 2003 as the base year period by simple aggregate method. Table contains commodity price in 2003 in rupees and price in 2005. So the solution to this, we are doing the computation of price index numbers. From the table, we have calculated sigma P0, which comes out to be 256 for the year 2003, and sigma P1 comes out to be 320 for the year 2005. The price index using simple aggregate method is given by the formula we know, P01 equals to sigma P1 divided by sigma P0 into 100. So that gives us 320 by 256 into 100, which is equal to 125. From this price index, we conclude that aggregate of prices of a given growth of commodities has increased by 25% over the period from 2003 to 2005. This method is an improvement over the previous method, as it is not affected by the units on which prices of the various commodities are quoted. The various steps involved in the computation of price index by this method are described as: first step, obtain the price relative for each commodity selected in the group. This is obtained by expressing the price of the commodity in the current year as a percentage of its price in the base year. Thus, capital P is equal to price relative for a commodity, which is given by P1 divided by P0 into 100. Step 2 here, obtain the price index for the composite group by taking average of the price relative obtained in step 1 using some suitable measure of central tendency. We normally use arithmetic mean, that is AM, or geometric mean, GM, to take the average of price relatives. Thus, price index using simple arithmetic mean of the price relative is given by P01 AM, that is equal to 1 by n times sigma P, which is equal to 1 by n times sigma of P1 divided by P0 into 100, where N is the number of commodities in the group. Second, price index simple geometric mean of the price relatives is given by P01 GM is equal to NT log of 1 by N times sigma log of P. So that is NT log of 1 by N times sigma log of P1 by P0 into 100. Now let's see an example. The example says the following table gives the prices of commodities in 1994 and 1999. Calculate the price index based on the price relative using the arithmetic mean as well as geometric mean. Let's see the solution. We're doing the computation of price index number here again. So from the table we have calculated N, which is equal to 6, sigma P equals to 753.1 and sigma log of P equals to 12.5653. So these are the calculations we have done using the table. Now using AM and GM formulas, the price index based on price relatives using arithmetic mean is given as P01 AM equals to 1 by N times sigma P. This is equal to 1 by 6 into 753.1, which is equal to 125. Price index based on price relatives using geometric mean is P01 geometric mean, that is GM, equals to NT log of 1 by N times sigma log of P. So this is equal to NT log of 1 by 6 into 12.5653. So this is equal to NT log of 2.0942, which is equal to 124.3. This method is based on the simple philosophy that each item in the group should be weighted according to its importance. In most cases, the importance of each item is measured by the amount of quantity consumed, purchased, or marketed. If small w is the weight attached to an item or commodity in the group, then the journal formula of the price index based on weighted aggregate method will be given as P01 equals to sigma P1 into W divided by sigma P0 into W. The whole thing is multiplied by 100. In this method, index numbers have been devised by using different types of weights as given below. The first one is Laspeyre's price index. It is a weighted aggregate price index which base period quantities are taken as weights. Thus the formula for Laspeyre's price index is P01 equals to sigma P1 Q0 divided by sigma P0 Q0. This whole thing is multiplied by 100. This formula was devised by French economist E. Laspeyre in 1871. Second one, Paasche's price index. It is a weighted aggregate price index which current period quantities are taken as weights. Thus the formula for Paasche's price index is P01 equals to sigma P1 Q1 divided by sigma P0 Q1. The whole thing is multiplied by 100 again. This formula was devised by German statistician Paasche in 1874. Let's see the next one, Fisher's price index. This index suggested by Professor Irving Fisher is obtained by taking the geometric mean of Laspeyre's price index and Paasche's price index. Thus the formula for Fisher's price index is P01 equals to under root of L into P. So that is equal to under root of sigma P1 Q0 divided by sigma P0 Q0 times sigma P1 Q1 divided by sigma P0 Q1. The whole thing is multiplied again by 100, where L is a Laspeyre's price index and capital P is a Paasche's price index. Let's see the fourth one, that is Dorbish and Bowley's price index. This index is suggested by Dorbish and Bowley, is based on the simple arithmetic mean of Laspeyre's price index and Paasche's price index. Thus the formula for Dorbish and Bowley's price index will be P01 equals to L plus P divided by 2, that is the arithmetic mean of Laspeyre's and Paasche's price index, which is equal to sigma P1 Q0 divided by sigma P0 Q0 plus sigma P1 Q1 divided by sigma P0 Q1. Whole thing is divided by 2 and is multiplied by 100, where capital L is Laspeyre's price index and capital P is Paasche's price index. So this index is also sometimes known as LP formula. Let's see the fifth one, that is Marshall-Edgeworth's price index. It is a weighted price index in which the weight for each item is taken as the arithmetic mean of the quantities consumed in the base period and the current period. Thus, the formula for Marshall-Edgeworth's price index is P01 equals to sigma P1 times Q0 plus Q1 by 2, the whole thing is divided by 2, divided by sigma P0 times Q0 plus Q1 divided by 2 multiplied by 100. So this is equal to sigma P1 times Q0 plus Q1 divided by sigma P0 times Q0 plus Q1, and the whole thing is multiplied by 100. This is equal to sigma P1 Q0 plus sigma P1 Q1 divided by sigma P0 Q0 plus sigma P0 Q1 times 100. Now let's come to the next one, that is Walsch's price index. It is a weighted aggregate price index in which the weight for each item is taken as a geometric mean of the quantities consumed in the base period and the current period. Thus, the formula for Walsch's price index is P01 equals to sigma P1 under root Q0 Q1 divided by sigma P0 under root Q0 Q1, the whole thing is multiplied by 100. Now let's come to the next one, that is Kelly's price index. This index is suggested by Truman L. Kelly, is a weighted aggregate price index and in which the items are weighted by the usage or quantities, which may refer to some representative period, not necessarily the base period or the current period. Thus, the formula for Kelly's price index is P01 equals to sigma P1Q divided by sigma P0Q times 100. Now let's see an example. From the following data in the table given, calculate price index numbers for 2007 with 2006 as a base year by Laspeyre's, Paasche's, Fisher's ideal, Dorbish and Bowley's, Marshall-Edgeworth's and Walsch's method. So we have to do all the methods here. Now let's see the solution. So we are doing in the solution the calculation for various price index numbers. Let's see how we have calculated all the columns in the tables shown for the commodities A, B, C and D, taking P0 and Q0 for the base year and P1 and Q1 for the current year. So we are seeing that we have done some calculation on the basis of this table. Now since we have done the calculation, we can calculate the various indexes now. Let's calculate the first one, Laspeyre's price index. So using the formula of Laspeyre's price index, we have calculated P01 equals to 3140 divided by 2660 into 100, which is equal to 1.180 times 100, which is giving us 118.05. So that is Laspeyre's price index. Now let's calculate Paasche's price index. So this is P01. Using the formula, we have 4114 divided by 3452 into 100, which is giving you 1.1918 into 100. So that is equal to 119.18. Let's calculate the next one, Fisher's price index. So using the formula, we have used the formula and we calculated P01, which is equal to under root 3140 divided by 2660 into 4114 divided by 3452 into 100. So this is equal to under root of 1.4068 into 100. So that is equal to 1.1861 into 100, which is equal to 118.61. The fourth one, let's calculate, that is Dorbish and Bowley's price index. So according to the formula, P01 is equal to L plus P divided by 2. So that is the average of L and P. So this is given as 118.05 plus 119.18. The whole thing is divided by 2 and we are getting it as 118.615. Now let's calculate the next one, that is Marshall-Edgeworth's price index. So for this, again using the formula, P01 is equal to 3140 plus 4114 divided by 2660 plus 3452 multiplied by 100, which is equal to 1.1868 into 100. So this is equal to 118.68. Now the last one, that's Walsch price index. So the formula for this again is P01, which is equal to 3587.62 divided by 3023.91 into 100. So this is equal to 1.1864 into 100. This is giving you 118.64. This method consists in assigning appropriate weights to the price relatives according to the relative importance of different commodities. The price index is then obtained by taking the weighted average of the price relatives. For the purpose of averaging, we may use arithmetic mean AM or geometric mean GM. Thus, the price index using the weighted arithmetic mean of price relative is given as P01 weighted arithmetic mean. This is equal to sigma W times P1 divided by P0 times 100. The whole thing is divided by sigma W. So this is equal to sigma WP divided by sigma W. So let's take this, let's make this the first equation. Similarly, the price index using the weighted geometric mean of price relatives is given as P01 weighted geometric mean. This is equal to anti-log of sigma W log of P divided by sigma W. So let's make this equation number 2. Okay, now let's see another example. The price quotation for 5 different commodities for the years 1990 and 1995 are given in the table. Calculate the price index for 1995 with 1990 as a base year using the two methods, that is weighted arithmetic mean of price relatives and weighted geometric means of price relative. So let's see the solution. In the solution, we are doing the calculation for price index using arithmetic mean and geometric mean. First one, price index numbers based on the weighted arithmetic mean of price relative is given by the formula P01 weighted arithmetic mean equals to sigma WP divided by sigma W. So this is equal to 10101.7 divided by 100. So 10101.7 is what we have calculated from the table. So this gives us 101.017. Second method, price index number based on the weighted geometric mean of price relatives is given by the formula P01 weighted geometric mean. This is equal to anti-log of sigma W log of P divided by sigma W. So this is equal to anti-log of 199.496 divided by 100, which is equal to anti-log of 1.9949. So anti-log of 1.9949 is equal to 98.83. So let's quickly revise what we have learned today in the chapter of index numbers. We have learned the types of index numbers, its uses, its problems, and methods of construction of index numbers, such as simple or unweighted method and weighted method. So that's bring us to the end of today's episodes. We are ending here the first part of chapter of index numbers, And we'll see you again discussing about our next part on index numbers very soon. Have a nice time. Thank you and bye.